Okay, so one of the problems that I think students struggle with in this lab is you're given all the chemical names written as names and not the formulas that you need them to be in for balancing equations. So I wanted to go through those really quickly here. It says cobalt 2 nitrate in your lab. Cobalt is CO, and nitrate ion, according to your ion list, is NO3. Now it says it's cobalt 2, so that means we have a positive 2 charge for the cobalt. So when we put them together, and nitrogen has a negative 1 charge. So when you put them together for the compound name, compounds cannot have charges. So it's going to be 1 cobalt for 2 nitrates in order to cancel them. So what that means is we had to have a second nitrate ion to have the positive 2 and the negatives cancel each other out. Well, without parentheses, the 2 next to the 3 makes it look like you have 32 oxygens. So you need parentheses around them to say, I have 2 of everything inside that parentheses. So that is cobalt nitrate. The same is going to apply for, it says in your lab, copper 2 nitrate. Well, a copper 2 is a plus 2 charge. Nitrate, again, is a negative 1. And they do not evenly cancel. So I need another nitrate ion in order to cancel. So the compound formula is going to be 1 copper and 2 nitrate ions. But I need to say everything inside here is the nitrate ion, and I have 2 of those. Another one in your lab is iron 3 nitrate. Iron 3 is going to be a plus 3 charge. The nitrate ion again is NO3, negative. Those do not evenly cancel, so I needed 3 nitrate ions in order to cancel the 1 iron. So now the compound formula, remember compounds have no charges, is going to be Fe. I only needed 1 of those, and I needed 3 nitrate ions, so 3 of everything inside there. The next one that your lab mentions is barium 2 nitrate. So barium is going to be a plus 2. Nitrate again is a negative 1. So that does not evenly cancel. I'm going to need another nitrate. So I have 1 barium. You don't write ones because it's weird. And I have 2 nitrates. So there's barium nitrate. Then we have nickel 2 nitrate. So nickel is Ni plus 2 ion, and nitrate again is NO3 negative. Those do not evenly cancel, so I'm going to need another nitrate ion. So the compound formula with no charges needs 1 nickel and 2 nitrates. So those are all the reactants that you mixed with. And now we have another reactant. The other reactants that you would have mixed with all of these reactants were all sodium as the first reactant. So sodium ion is a plus 1. So depending on what it's mixing with and what its charge is going to tell you how many sodiums you need. So the first example was sodium phosphate. The phosphate ion, according to your ion list, is a negative 3 charge. So that means I'm going to need 3 of these sodiums altogether so that I have altogether a plus 3 charge. And that's going to cancel the 1 negative 3 phosphate. So how many sodiums did I need altogether for the compound formula? I needed 3 of them. And I only needed 1 phosphate ion. So that's the compound formula for sodium phosphate. The next one was sodium iodide. So sodium again is the +1. It's in the first column on the periodic table. Those are all +1s. Iodine is in the halogen column next to the noble gases, and those are all a -1. Those evenly cancel, so we end up with one of each. So the compound formula is Na with a capital I. Notice the A is lowercase. All the second letters are lowercase. So that is sodium iodide. Then the next one was sodium sulfate. Now again, we have the sodium ion, which is a +1, first column on the periodic table. The sulfate ion is always SO4 with a -2 charge. Now that's in your ion list again. Notice those do not evenly cancel, so I would need a second sodium ion. So the compound formula with no charges is I have 2 sodiums and 1 sulfate ion. Another one of the reactants was sodium chloride. Sodium is a +1, chlorine is a -1. Those evenly cancel, so I end up with NaCl, which I'm sure you've heard before. Then we had sodium bicarbonate. Sodium again was a +1 charge. Bicarbonate was HCO3 negative. Those evenly cancel. So we have this as the compound formula, NaHCO3. Running out of room here, we have 2 more. We had sodium was the +1. Carbonate, not bicarbonate like the previous example, is CO3. And that has a -2 charge. So I needed a second sodium ion, and that means the compound formula is going to be Na. I needed 2 sodiums per 1 carbonate ion. And the next one is really important, sodium hydroxide. It's a base because it ends with the hydroxide ion. Sodium is a +1 charge. Hydroxide is OH negative. So those evenly cancel, and we can put them together 1 to 1. So we have sodium is Na, hydroxide is OH, and that's the sodium hydroxide ion. So the combination of these reactants will give you the different reactions that you had for this lab. So you just need to pick 5 of them to match up together and balance those equations.